Hello everyone, my name is Ruffin, and today I'm going to be talking about SROS, securing ROS over the wire, in the graph, and through the kernel. And this will be about some of the work I did at OSRF with Morgan Quigley. And as an aside, if you're a fan of sci-fi fiction and philosophy or cybersecurity and robotics, you might get some of the references I had dropping my slide. All right, so what is SROS? SROS is an addition to the ROS API and ecosystem to support modern cryptographic and security measures. And so we'll be going over three main sections today: encryption, access control, and process profiles. And so what you see here is a general overview of some of the topics we'll be delving into deeper. And so now I'd like to move on to some of the motivation for some of this work. Why SROS? And so one thing is, like, robots provide a vector for cyber threats to manifest in the real world risks. And I don't mean just like physical risks of industrial arms being hijacked or autonomous semis being taken over on highways. It could be also privacy concerns. So with robots becoming more ubiquitous in the home or commercial sector, privacy and data can be a concern as well. And so specifically on a ROS-related note, there's some vulnerabilities of ROS you should be aware of. So ROS's transport is all in clear text, and so that's really susceptible to packet sniffing and man-in-the-middle attacks, and so you lose confidentiality and integrity of your messages. Also, ROS's computational graph is anonymous, so nodes coming into the graph don't have names, and so it's easy enough to spoof another node or go rogue, and so you can start publishing and subscribing or calling service calls you necessarily shouldn't. Also, runtime processes. So if you're writing ROS nodes, they might have zero-day exploits hidden inside them for possible code injection. And so how can you guard against those possible attack vectors? And with that, some of the on a side, I'd like to address, well, why wouldn't you just use VPNs or software-defined networks to address some of the task issues I've mentioned before? Well, they certainly have their pros. If you're tunneling over distant networks, you might know that ROS allocates ports during runtime. So if you want to build an ephemeral port firewall, that's like playing whack-a-mole. If you also VPNs, they have professional routers and switches, and so if you'd like to offload the cryptographic overhead to another hardware system, so your robot CPU isn't burdensome with the ciphering all the network traffic, that can be an advantage. Also, existing infrastructure, so if you're doing anything with cloud robotics or AWS or Azure, so like they all have VPNs and software-defined network interfacing. So it's a mature technology, it's well documented and pretty well understood. But there are some cons. So session hijacking, or someone gets physical local access to your network, the ROS protocol is still exposed. Stack complexity, so you might not only be dealing with ROS now, so you now know how to use OpenVPN, you have to keep it up to date, you have to configure it so you're not accidentally shooting yourself in the foot. That can be an issue. Also, fine-grained control. So if you want to do anything fancy with the ROS graph network, you want to have a void noise system of certain overlaps and exclusions within your ROS computation graph, that can be kind of hard to manage yourself with subdomains. All right. So we talked about some of the issues. Let's talk about some of the solutions that we're providing with SROS. Encryption. So this is addressing some of the over-wire transport issues. We're adding public key infrastructure and transport layer security. And so what that affords you is, you can start using X509 certificates to utilize asymmetric keys. You can also use the certificates for signing. You can have certificate authorities and the chain of trust. And so when robots go out of your system and they start talking to each other in the wild, they have a means to identify, validate, and see if each other's expired or revoked. And there's a lot of cool security things you can do with certificates. with the transport layer security, not only is your traffic encrypted, so you have the privacy and integrity, but also forward security. So if anyone's been like logging your network traffic and then later recovers the private keys on your robot, they can't necessarily uncipher all the traffic they've recorded. And so that's done by like wrapping on a socket level all the XML RPC and TCP level communication that ROS uses. Another thing is I'm of a strong opinion that security without usability is not very secure. So if users don't have the tools and infrastructures to readily use security measures, then they won't. And so one of the things I tried to develop is a key server and key stores that's a simple API and interface for you to auto-generate certificates. If you're at all familiar with using OpenSSL or any kind of IT infrastructure to generate certificates yourself, you'll know it's a very tedious and laborious process, and again, just like OpenVPN, it's easy to shoot yourself in the foot. So what I've tried to do is provide sane configuration defaults. What you see up above here is like stuff like Wireshark introspecting the network communication handshake between two nodes, using Ubuntu to examine the certificates that are on your in your key store, and then like the configuration file that you can kind of give to the key server to customize your certificates and auto generation. All right, access control. So let's say a node gets on your network. How do you quarantine or limit the scope of what kind of damage they can do? And so when you have certificates, the other cool thing is you can use the extensions to embed, say, policies or permissions. And so if you're familiar with ROS, everything uses namespaces for topics, node names, services, parameters. And so what we do there is we're using something like AppArmor's globbing syntax to allow you to flexibly define what regions on the graph are read access, or what a node has write access to particular topics or nodes. And that's really cool. Auditing and security logs. So we're adding auditing to all the access events and the violation attempts. So you have you can also adjust how flexible your system is. Maybe you just want to set your robot in audit mode, see what the violations are, and then you might want to set an enforce, so you just reject any violations outright. What we can also do is we can take those security events and use them to train policies. So if you've ever did a ROS graph, or like you printed out the PDF of all the nodes and you see all the interconnects, handwriting a policy for that would just be insane. And the common kind of thing to do is like an AppArmor is you run your application for a while in training mode, take all the events and then compress that into a policy. And so what I've done there is I've allowed you to auto-generate sort of a human-readable YAML file that then the key server can use to generate the certificates. Demo time. So if you're interested in following me along, I use Docker, so you can run this on your own machine if you want. But this is like a terminal recording, so you can copy and paste commands out of it if you need to. Well, it's a good thing I just left it up here. Access, yep, cool. All right, so what I'm doing here is I'm just pulling the OSRF's SROS experimental container, so you can get started with that. That drops you into a Catcoon workspace with everything built. Right here I'm just sourcing the bash RC, so I don't have to do it all the time. Then I use Bibo, so we can start doing multiple sessions really easily within this container. Then I delete the default .ROS configuration I had for the demo. So this is like if you were doing it yourself from the from starting up. What we do here is we start the SROS key server, and that generates the root and master certificate authority. If we check the tree, you will see we have the key store, the CA for the master and root auto-generated, some links for OpenSSL that needs, and some configuration files. Here's the default configuration file. It's commented out, so nothing's configured right now. What we'll want to do is we'll want to train a profile automatically. So we've started SROS core in train mode, so any violations are then going to be amended to the policy. So then if If it sees a new policy violation, it'll amend it, and then it won't see it again. All right. So now what we're doing is we tried to run the talker listener, but it failed. I'm going a little bit fast here, but you guys can go back to the demo and slow it down if you want. Now we see the auto-generated file. It's been expanded and populated. You see all these particular things that just a simple talker listener example was doing. You certainly want to debug that by hand. Then what we'll do is we'll remove the first generation of certificates that were generated. They don't necessarily have these policies, so we'll just wipe them out. And then we'll query the key server by launching everything again, and then everything will get new certificates with the latest policy invoked. Yep. So you can see the events of when things were generated. Relaunching the key server. Going back to ROSCon, we can remove the train. Now we're in enforce mode, hardcore. Here you can see like a blurb of the certificate of the particular unique ID that was used to define the permission. So this is all written in the documentation for the SROS wiki. But you can see the policy qualifiers, and here's the chatter topic. Here's the ROS out for logging, so the node has permissions to publish its own logging message. Yep, and this is the same, but for the ROS master. So the master itself is also a node, so it needs its own certificates to interact with the other nodes within the network. And then I go ahead and take the key server offline and then restart everything. And so what you can see is now that all the keys have been populated into the key store, you can take the key server offline, and that way your system's kind of locked down. There's no certificate authority allowed to sign more keys. So you might run that on the same robot, or you might run that within your workshop on a separate computer, however you wish. Okay. All right. So process profiles. And so what we're doing here is we're taking account for the onboard processes. So there's a thing called Linux security modules, and what those do is they leverage pre-existing kernel level security features. And there's two big popular ones, SE Linux and AppArmor. What we've done here is we're just using AppArmor for its its easy user access, and it's also pretty well documented. The other thing is Ubuntu and Canonical already have it in Ubuntu, so it's easy to start for most ROS users there. What you can do there is you can quarantine ROS processes. You can limit it's more of a more fine-grained control of the Unix user permissions module. You can limit file, device, inter-process signals, networking permissions, so nodes can't SIG-int kill other nodes. What we've done here is we provided a ROS profile library, so you can quickly get started. Here's an example, but what I'm going to do here is go ahead and show you how easy it is to get started. So what it entails is you can clone the current profile, then move the relevant files into your own Etsy AppArmor profile directory. From there, we can see there's some basic primitive files for the library. Here's a example template for ROS launch, ROS master, ROS core, and so they're using the abstractions within the library to just simplify a lot of the tasks. And so here's the talker and listener example for C++ or Python, and so what that might look like. From here, what we can do is we can launch an example setup. So with ROS core and then the talker and listener, and you'll see under the AppArmor profile that's enforced, they work just fine. But then we go and do something malicious, we add a evil script to your logging directory that deletes things. All right, and then we try and run the same node again. And so what you'd see is because we already have the AppArmor profile with the ROS library enforced, we see, oh, the process doesn't have permission to do that. So that's really cool when you can like have fine-grained control over what a node is able to do. All right. So, to-dos. So there's certainly some to-dos. We want to develop a ROS enhancement proposal to kind of standardize a lot of the public key infrastructure practices, what specific object identifiers we're going to use in our extensions, a lot of technical details like those. We want to add some more support for different client libraries. Because the ROSCom and ROS core is all written in Python, for rapid prototyping, that's where we started. But we certainly want to add like ROSP Java. TLS is a stateful connection, so I'm not exactly sure how to approach the UDP and multi-broadcast, but I think there are some equivalents in that direction. We want to harden all the master and slave API calls. So, you know, there's some system-level API calls in ROS, like shutting down another node with API XML-RPC, and so, you know, you want to make sure only a master is able to call that. Unit test coverage, unit test all the things that needs to be done. Abstracting security modules and plugins. This is what I've done a little bit already. So if you have a different schema of auto-generating certificates or enforcing policies, you can define that in the certificates you generate, and then you have a logical plugin to evaluate that during runtime to see whether, you know, a node you're connecting to has access to this particular event it's requesting. One thing I like to do is give a shout out to OSRF and my lab at UCSD. Without their support, this wouldn't have been possible. All right, some resources for the SROS wiki documentation, the Docker file to get you started if you want to start developing, and a little bit about me. So now I'd like to open up for questions.
What's the overhead like network and processor?
The overhead? So I think Morgan did a unit test. You want to explain what you had with like a small Raspberry Pi?
Sure, it's a great question because of course there's always a penalty when you add more processing. But what's great about this is the fact that we're using TLS for this prototype means that since everything, you know, internet-wise is gradually migrating to HTTPS, there's tons of support in the OS and actually in the chipsets lately. There's actually like, people are using specific instructions in the ARM and x86 worlds to make this stuff go faster. So as one milestone, it was like a couple more % on my laptop to stream a webcam over using this, using ROSPi. We wrote like a ROSPi version of a image viewer and a webcam streamer just to kind of like, you know, test it with high bandwidth data. And it was like, it would take like 8% of a core on my computer to run that without encryption, and with encryption was like 3% more or something like that. So it's you can measure it, but it's not, it doesn't like wipe out the whole system because there's so much support for doing this stuff nowadays.
The main overhead I've been told for like TLS connections is actually the handshaking method when you're trying to validate a certificate, or like running down the chain of certificates to make sure everything's validly signed. That can be computationally heavy, but then ciphering is not too bad now, and I think a lot of processors have like an instruction set just for like that particular task.
Really cool work on this SROS stuff. I think security is a thing that we all definitely need to think about with our robots, and we've not done so much before. I do have a question about openness and how ROS is currently configured. Nodes come up, nodes come down. Sometimes you might want an unknown node to attach to your ROS master. How do you deal with that with all of these signed certificates?
So there's like there's a slight separation between the transport security and author authentication. So what you can do is you can set, I have the documentation where you can set environment variables to configure how flexible you want. So maybe you just want the network encryption. You don't necessarily need or want to bother with the making the graph non-anonymous. So you can leave the graph anonymous if you so choose, and then it's just following a lot of the PKI standards, where if it's in the certificate, then it must be followed, but if it's not, so then what you could do is you could just omit that from the certificate, and then nodes could like connect to each other, but they wouldn't, there would be no policy evaluation on what they could or could not do.
So this gives you fine-grained control over having some nodes that are incredibly secure and then some nodes that are relatively open to incoming connections.
Yeah, so you could section one portion of like mission critical event nodes that are only accessible by particular policies or like particular nodes signed by a particular certificate authority. So there's a lot of cool stuff you can bring in from the IT infrastructure with certificates.
No, really cool. Thank you.